Good morning, friends. We are here to have our webinar, that is ISTE approved webinar on advanced topics in Python. We Navyog Vidya Bhavan Trust driven C.K.Pithawala College of Engineering and Technology at Computer Engineering Department welcome you all. Let me introduce our expert speaker, Mr. Nishant Gandhi, who is Senior Software Engineer at Data Robot Inc., Boston, USA, who is alumni of our college. Not only alumni, but he was a very good student when he was studying here. After that, he has done his master's from IIT, then studied at USA, and thereafter he is working at this institute, that is, we can say this company, and working very well in the field of machine learning and Python, as well as he is working with deep learning also. So let us have very good knowledge from him. He has helped us in organizing various workshops at our college. We are thankful and welcome to our speaker, that is Mr. Nishant Gandhi. Thank you, Mr. Nishant Gandhi. Please start your talk, sir.
Cool. I hope everyone's doing great. Thank you for joining for today's talk. And of course, thank you, Dr. Ami Choksi, for inviting me today for this talk. Uh, so let's just dive into it. I assume that all of you guys already studied Python a bit, or have a basic understanding of Python, because for today's talk that will be essential. Now, why we are doing this topic, and why this is important that we are talking about right now. So when I started, teaching Python, I teach Python around here. And when I started teaching Python, I saw that most of the people teach Python, like very essential basic Python, but not the level, or not at the part where industry use the Python. So there is a gap between how people in industry who are seasonal software engineer, they use Python in day-to-day work, and you know and the people, and the simple topic that is being taught everywhere. So that to fill that gap, I created this particular program where I cover slightly advanced topic that people normally use day to day, in their job, those who are actually using the Python. So I will be covering all these topics. So tomorrow, if you go in a market with with having the resume with your Python skills, and if you can showcase these skills, I would guarantee that people will take you as a serious Python engineers, because there is an idea that certain thing. I mean, to know the language well, you need to know the actual essence of the language. Like, uh, so if you are able to understand, use these things, this kind of concepts, this topic that we're going to talk about today, and if you can showcase that you know them and you can use them very well while writing your Python code, definitely you will check in the expert in Python. So this is the gap, this is the topic, this is the thing that you need. If you have them in your resume, if you have them in your mind, while working on your Python project, that will really showcase that you are a really expert in Python, and not just can do some minimalistic work. So that's why it is important. So uh, and I hope you guys will have a good time learning all this topic. I will try to keep it as easy as possible, and please, once the whole topic is done, I will share the notebook that I'm presenting today, so you guys can go and practice. We're also going to have the recording, so you guys can revise the topic and revise the concepts and ideas, and make use of this. So with that, let me try to give you overview of topics that we're going to cover today. So startingly, we're going to learn about functions in Python. You know what functions are. You have learned them in C++, and hopefully Java also. So why it is different in Python, and what makes functions special in Python. So we're gonna cover about that. We're gonna cover some other advanced topic around comprehensions and generators. You might have already done this before, but These are really important. People who know comprehension generator, I will tell them this. These people know the Python, because these are the very essence, very idiomatic Python, as you can call it, like something that is very native and very unique to Python. These kind of ideas and concepts. So if you know them, then people will take you as someone as a Python expert, because these things are very native to Python and very close to Python. Map, filter, reduce, these are functional programming ideas, but very useful. We will look into parser functions and decorators, and parser functions and decorators are also very important. Parser functions are very unique to Python, so you will have good time. And decorators are also used a lot in industries, and people going to industry with minimalistic Python knowledge really face problem when they don't know how decorator works. So this is very important, useful things. If you know all these things, if you know all the things that I'm going to teach today, you will have very successful, job interviews and showcasing your Python skills. So let's get started. So first thing, Python functions. Now we know what functions are. Functions are basically either you can think of mathematical functions or general functions. They take the input and they give you the output, and then and that's how they're. That's the job of the function, is like take the input and give the output. Now in the programming language, Python could be something called first class citizen or second class citizen. Now what does that mean by first class citizens, second class citizens? So today, every programming language is a thought around objects, right? Uh, and when you think about, let's say, any other programming language, you can pass object into another functions or into classes, right? So in the C or in the Java, when you write the function, you can pass the argument, which are variable, into the function, right? Because that is the input. Um, but not every programming language allow you to pass function as argument in the another function. So the function programming language where you are allowed to pass function as an argument, this programming language have function as a first class citizen. Now why so? So in the languages where you can pass one function into other function as an argument, in this kind of languages, function are also considered an object. They are not a separate kind of entity. They are similar to any other object. So functions are also same as any kind of class instance or any kind of variable. So that's why because Pythons are considered as an object, and they are considered similar to any other variable, they are called first class citizen, and you can really pass one function or another function. So let's see what I'm trying to tell here. Demonstration will make more sense. So here is your function, def, which says this tells that we are trying to initiate the function. This is the name of the function, opening closing parameters, colons, and then return, and then return. So this is a very simple function, which basically when you call the function, it will return the hello as a string. Now now let's learn about what this thing, what this whole thing represent. So if you know, in the Python, if you want to learn about type of any object, you just wrap the whole thing around type, and and to learn what is the type of a particular object that you pass. So when you have a function, so when you pass a function object, and when you say type, so it says it's a function. So this behave very similar to any other kind of like uh, let's say 10, which is basically a number. So it's a type integer. So like a variable, your function is also behave very similar to how it would behave, how any other object would behave. So that is the first point. Like your function is also an object, and it behave like an object, and you can apply all kind of functions and methods and other kind of tricks that you would apply on any other object. Uh, so that kind of reinforce our point that function also treated as an object. Now let's see how when I'm declaring the function, it has all this def. This is the parentheses. I'm not using all of that. I'm just using the name of the function. Because I'm only using the name of the function, I'm basically trying to represent the object. So if I try to print, you can see this kind of a memory, a definition of the function, that it's a type of function, and then main is the our current scope, and then dot func. So it tells that how what this thing is. This is basically uh, and function is basically an object here in the Python. Now, a couple of things that you can do with the function object. So what you can do is you can print all the attribute of a function. Now, printing all the attribute is something you can do with the object. Uh, and when I say object, so when you, let's say if you create some class and then you initialize the class, then you get an object or instance of a class, which you also call an object, and you can print all the attribute. So similarly for the function also, you can print all the attributes. So these are all the attributes that your function has. And you can use this dir, and it will print all the attribute of a certain object, because function is also considered an object. So this is the technique that you would use on any normal object, any normal class instance, and that work very similar to on function, because your function is also an object. So so you can print all these methods that is that is available to the function. You might be knowing this init method particularly. This is the constructor for Python. Or doc, we'll see the doc and dict and format and other kind of things, str size of, so all those things. Now when you want to, when you want to treat or want to see a function as an object, you basically like pass without parameter, just the name of the function. But when you want to call the function, you add this parenthesis. So difference between this function, so this function is basically an object, right? But when you want to call this object, when you want to execute the function, you add the parenthesis and then it will be called, and then you are executing the function and you get the result or whatever output the function is. Now just like any variable, you can reassign the variable names, same as you can also reassign the function name. So as you can see here, our function that we have defined is called myfunc. So now what I'm doing, I'm creating this new variable called newfunc, and newfunc equal to myfunc. So basically I'm just like passing any object, I'm just copying the object into or copying the reference into another variable. X equal to a, a equal to x, so a equal to a, so things like that. So you can also do the same thing with the functions also. And now that I'm calling new func, it will also behave just as my func, because this is the something that you can do with the any kind of objects or variable or object instances, where you can reassign them, you can re-reference them. So all those things you can do with the functions. So I just created this new variable, and I say that this new variable equal to my this function equal to this function, and I get the and my new, and basically renaming my function or creating new variable that is assigned to my this old function, and then it will just behave like original function. So the point that I'm trying to make here is, in Python, your function is not something special. In Python, your function is basically it basically implemented as an any other object, like any other class object, or any other instance of certain class. So function behave like that. And because your function is basically just an object, it can work with different kind of you know uh, other mechanism that we have in Python to work with the object. And you can do all kind of things that you can do with any normal object. You can rename that, you can pass around them, you can call different methods on them, like dir, which is basically printing all the attributes. And we will see a couple of other mechanism also that is normally available to object, and that is also available to Python in the Python functions. Now, we so this is all about like so first point we made this here is a function is an object in Python. Now second thing, we are talking about in the Python, uh, the functions are higher order functions. Now what is the higher order functions? So just definition of higher order functions. So any function that can take another function as an argument are called higher order function. And based on how many how uh, how many deeper you call these functions, based on that you can say first order, second order, third order. So it says that first order function takes no functional argument, so this is the only variables. Second order functions can take first order function as its argument. So second order functions can take first order functions. So what are first order functions? Functions with only variable. So second order is a functions that takes first order function as an argument. So we'll see an example. So here we're going to see the example of second order functions, and third order it can take second order function as an argument. So calling function to function to function. But basically the idea is, because you can pass one function as an argument to another function, uh, this whole mechanism or this whole capabilities of function to be able to pass around function into each other, because of that they are called higher order functions. So your Java is not Java, I think, at least until Java 7. I'm sure for Java 6, not for Java 7, because Java 7 introduced some other features. But until Java 6, Python, Java was not higher order function. You cannot really pass functions into Java's function. So when you have Java function, Java method, you cannot pass a method as an argument into Java. So they are not higher order function. But Python is a higher order function, because in Python functions, you can pass another function as an argument. So let's see what I mean by that. So here we are looking at one example. We have one method called mySum, which basically takes two arguments, a and b, and we are basically returning the summation a plus b. So pure integer style variable, or it could be integer, string, or whatever. But basically they are not functions. A simple variable, a primitive variable, mostly. You're passing a comma b, and you will return the sum. We are in another similar function called mymul, basically multiplications, where we have a and b, and then we are multiplying them in the return. So see them as two functions, and because you can see that we are not passing any function as an argument, these are just pure integer, assumably integer inputs. These are called first order functions. Definition of first order functions: takes no functional argument, no function arguments. There are no functions being passed, just pure non-function variables. And and now we have this another function where we have three arguments, out of which first is a function and second is a and b. So this is a second order function. Why? Second order function takes first order function as an argument. So here we are assuming, or we are expecting this myfunc to be first order functions, and then is one of the arguments, and then a and b is just simple variables. So now let's call this myfunc. So what we're gonna do while calling the myfunc, my executor, inside the my executor, we're gonna pass our first argument as a function object, and then second and third as a input to doing some summation, just integer values. So when we run the whole thing, you can see output is a 6. Now what did we do here? So my executor, we have introduced this function. This function takes the first argument as a function. So here we are passing mymul as a function object into as a myfunc, and a and b as a variable. So what it returns, whatever function you pass in the parameter, it takes the function and call the function by this parenthesis, and passing the same arguments a comma b. So here mymul will be passed to myfunc, and now myfunc equal to mymul, and then a comma b will be just passed as it is. Now just to do the same with the mysum. So the same thing, when we are passing mysum, which will be a function that will be passed into my executor a comma b, and it returns basically myfunc is mysum, so mysum a comma b, and that's what is being called, and you get the value 5. So the point here is in Python functions, you can pass another functions as an argument, and then you can use them. And this is why in Python functions are called first class citizens, because they are treated as an object, and they are higher order function. That means you can pass function into another function as an argument. So this is the main difference between let's say Java functions in Java and function in Python, or a lot of other programming language. So this is the advantage in Python, that because you can now pass function as an argument, you can do so many things that you would not be able to do in something other languages that cannot allow this kind of behavior. So because Python has this behavior of you can pass function into another function, it can do a lot more things that other functions cannot do, other programming language may not do if they don't allow this. So so point taken. Now let's move to the couple of other things that you can do with the functions. One thing that Python has, something that Python can do, that you can actually extract the doc string. So we use this a lot every time. So let's say you want to create a documentation of all your functions, right? And to create the documentations, you want to have all this, you want to tell that, hey, these are all the APIs, these are all the functions, and this is the behavior that it does. So how you can do that? So every time you define the function, you can either in single quotes or in three quotes, you can pass something called doc string. So this is called doc string, which is basically a string, which basically it's kind of comment, or you tell what this function does. So you can, with every function in Python, you can create this kind of doc string, and this is a string. So in Python, you can either do like single quotes or three quotes. Same thing. Normally, three quotes is for multi-line, and single quotes is single line. And you assume that your description of your function going to be multiple lines, so that's why we use three quotes for multi-line comment, basically multi-line string. And so if you write a function, and if you write a doc string like that, you can extract the doc string by something by using this internal function called underscore underscore doc. So let's run this thing. So as you can see that with every function, you can basically write this kind of doc string, and that doc string can be extracted using underscore underscore doc. Now this is the behavior. Imagine like where you can like do this kind of thing in which kind of scenario, in the object, in the class object. You can have the class object where you have object, and object can have attributes or properties, and then you can print the properties. So your function here is treating more like like an object, because now this object has a property, and this property has certain values. Normally your object has a property and the values. This is something you won't see any in a lot of other programming language, where your function can have properties or your function can have attributes. But in Python, your function has an attribute because your function is itself is an object, and it has multiple attributes as an object. And we printed so many of them here. So what we are seeing right now is underscore underscore doc that we printed, which was one of the default attribute that comes into the function. And so yeah, now let's try to extract something for some inbuilt function. So Python come bundled with some automatic functions or some predefined functions or something that come as a bundle in the programming language. So one of such function is called sum. You can do sum on on the array, on the list, and basically get the output. So sum is a function, right? And it also has underscore underscore doc string. And this is what a default sum function that comes with the Python. This is a doc string that sum has. Return the sum of start value plus the iteration of the num value. And you can actually look at the Python doc. So Python doc sum. So this is the Python documentation, built-in functions, and we are going to sum. And you can see here the document of the sum. Sum start, and the item of the iterable from left to right return this total. So that you can see here. Now I have different version of Python, and this is different version of Python. So doc might look slightly differently. It says change in 3.8, the start parameters. I'm using the older version of Python. But what the point here is, as you can see, there's a documentation here for all the functions, all the methods that comes along. So how it happens in the Python, when you write the code, when you define the function, when you write the function, you can actually write the description of the function in the doc string like this, and that doc string can be used to create the documentation for your functions and for your methods, so even for your classes. So that is how doc string is being used for for a lot of purposes. Say you are creating APIs, right? API for your application programming interface, or APIs for your customers. You are building some kind of software that comes with APIs, and API need to be documented so people can know that what is the API means and how they can use them. You can either APIs or libraries. You can say libraries, right? So when you are creating your own library, you need to tell user what your library does and what are the arguments, all the description of your library functions, right? So this is how you basically document all the things. And once you have documented all your functions in your library, you can basically extract them and create the document out of it. So this is why this is important, and this is why this is used in industry. Um, this is more about what function is, and more about the idea of the function in Python, and how function is being treated and how function is being designed in Python. Now let's go much more deeper into some. So you know how to use the Python, how to use the function, right? You write the def, you write the function name, and then you pass on the parameters a comma b comma c, and then you do with whatever you want to do with abc. Now, something else that you might have seen, it's called keyword arguments in Python. Now, you may have encountered somewhere, if you are reading the open source programming code, open source Python program, you might have seen this kind of keyword arguments in the function. So what does that mean, and why and how they are different than normal argument? So the obvious behavior or obvious pattern that you can see is there is a star in front of the your parameter that you're passing in your function. There's a star, a kind of a wildcard thing that you use before your parameter. So what does that mean, and how that change something like, what is the difference between def my func let's say um, a. What is the difference between not having star and having the star? So let's learn about that. So let's write this function, and what we're going to do is we're going to print our arguments here. Okay, so we have defined the function, we are printing the arguments, and we are printing the type of the argument. And in my function, I'm going to pass 3 parameters. Although there's only 1 argument, I'm going to pass 3 argument here. Why? Because of the star, I can pass multiple arguments. So how Python function treat them? So here we are seeing, so in the my function, which has this wildcard and arguments. So what you're passing is 11, 12, and Rio 3, 2 integer, one string. We are passing it here, and we are printing the value of arg. So what is arg? Arg, we receive arg as a tuple, and you can see the type of the tuple. That means every time you pass an argument in the function, and if the function is defined as as the wildcard star args, it will take all the argument as a tuple. So this arg is basically a tuple, and everything that you pass will internally create as a tuple. And I assume that you are familiar with the tuple data type, which is basically list, but like a fixed list where you cannot change the list, something like that. So this is a list or tuple. Technically, this is a tuple, and then you can use all this variable. So now let's what happened instead of this single variable, like like we are passing 11, 12 as a 3 parameter. This is a b c. There are 3 parameters here. What if I'm passing just 1 parameter as a list into it? So as you can see, this is still a tuple, but in case of this tuple, your first uh, first element in the tuple is going to be the list, and second, so there's no second element. So this is how tuple being represented when you have only 1 element in the tuple. You have this comma sign, and then there's no space, and this is also tuple. So every time you see star args, a single star arg, that means every argument that you're going to pass will be converted into tuple, and then your arg will become a tuple, and then you can extract element one by one, like as you do with the tuples. So how about 2 arguments? So 2 stars. So sometimes you see 2 stars, which is called keyword arguments. So this is wildcard argument, and this is called keyword argument. Difference: your wildcard argument have only 1 star, and your keyword argument has a 2 star. So what is 1 star and 2 star has indifferent, and how they are different basically? So your 1 star will take all your arguments and convert them into the tuple, and your 2 star will convert them to dictionaries. So likewise, just to see how it works and how the keywords are interpreted, I'm gonna create this function. with the keyword, as a function has a keyword as an argument with the 2 star, and we're going to print the keyword and we're going to print the type of that keyword. And what I'm passing here, I'm passing here key value pairs, or basically, variable name and values. So as you can see here, when I'm passing n1 equal to 10, n2 equal to 20, so it will basically become a dictionary where your left part will become your key and right part become your values in the dictionary. So this is what happens. If it's a single argument, like single star and argument, it's gonna convert everything into tuple. But if you're gonna have your 2 star keyword argument, it's gonna convert everything into dictionaries. So these are the two cases. Now let's think about the third case where you have a function which has single argument and single star argument and double star keyword. So how it is going to behave? So I'm going to do the same thing. I'm going to print the arguments. I'm going to print the keywords and see how the whole thing behaves, right? So let's do that. So I define the function, I execute it. So now function is in the memory. So first thing I'm going to pass in my function is a simple arguments like 11, 12, and hello. There is no key value pair. There is just a single values separated by commas. So if you can see here, my args will take all of them and create this tuple. In my dictionary, keyword args, because there is no key value pair, it will stay empty. So my args will take all of them, and my dictionary will be empty because there is no key value pair. And same goes here. When I in the my func3, which has args and keywords, when I execute them, so because these are key value pairs, so these are like a variable name with the values. You see, um, tuple will remain empty because there is no single value here. There is all and only pairs. So because there are only pairs, they will be defined into the dictionary. Now let's see what if I'm passed combination of them. Like passing some of them as an argument and rest of them as a key value pair. So you can see them, the part uh, which was single elements combined themselves into tuple and went into args, and the rest of the piece, which was key value pair, went to the key value section and then became the dictionary here. So this is the mystery of single star argument and double star keyword, and this is something that being used a lot. Uh, you know. um in the real world scenario, you will see many time more than single star double star keyword will be passed, and based on your input, your function will behave differently. So uh, so yeah, instead of sometime people use that sometimes, instead of passing a single dictionary, your function will allow you to pass as many number of key value pairs like this, and which will internally convert it into dictionary. And that is something is being used a lot in industry, so that you may see. So hope this will clear the funda of this wild card or dynamic arguments with single star and double star, single keyword double keyword. I will take a pause here before we move to the next. There is one more piece here, but I will say it for the later if you have a time. This is more like a very weird corner case, kind of cautionary tale, like not to do that. Before we go to lambda functions, I'll just check messages and see if we have any questions around here. Does anyone has any questions until now for whatever we saw until now? Functions, objects, function being object, function being a higher functions, doc string, dynamic arguments. Is it all clear? Pick yes, no, or questions. Okay, so are we still having problem understanding some of the concept? Do you want me to go over again? Is there any other feedback? Am I clear enough? Should I reduce my speed? You guys can unmute. Okay, keyword argument is something I should do it again. Anything else? So my first question, please type yes and no. Are you aware of dictionaries, dictionary data type, and comfortable using dictionary data type? Okay, I see some no, some okay, yes, yes. Okay, okay. So I see I get one no, some yes, so I assume that some other people know, some other don't. Um, So what is dictionary basically? Dictionary is basically key value pair, right? In the Python, we have this special data type where where the data type is defined by key value pairs, and it's simple key and value pairs. There's a key, there is a value, and there are a bunch of them. So if you want to access any key, uh, you know, so let me give you a quick reminder on dictionary. So you can create a dictionary by key value pair. This is an example of a dictionary where you have B1 as a key, C as a value. I'm going to call it my dict. So this is your dictionary. It has a key, it has a value, and this is how it look like. Now, how to access the dictionary? So with my dict, what you can do is you can just say that, hey, give me the value of B1, B1 passing being in a square bracket, and you will get the value of B1. Or you can say get me the value of C, and you get the value of C. Simple key and value pair. You pass the key, you get the value, and it's easy to even add or replace the key. Or so if you, let's say I want to add new key, I say let's say C1 equal to 30. So that is simple assignment operation. And now if I see what is my dict look like, so now it has this new C1 assigned to it. So simple assignment. I can modify the value. So C1 equal to, let's say, 45. So I'm just reassigning the my dict C1 equal to 45. And when I print my dict, so value has been changed to 45. So this is a dictionary data structure basically. Now, in the Python functions, what happens is, you are allowed to pass dynamic arguments. So there's a function, and in the function, you are supposed to pass some kind of argument, and this argument will be used by function to do the processing. Now, either you can do simple, like a simple function where there's a a comma b. That means you are supposed to pass a and b. There is a strictly two values. You can't do one. You can't do three. You only have to do two, and it has to be a and b, and that's what you can do about it. And that will be used, and a will be available to do whatever you want to do. Like let's say return. If you want to do a plus b, you can do a plus b here. Simple. But what if you want to have a variable number of argument? That means a number of argument that you pass, you don't want to assign. It could be a, it could be a b, it could be a b c. So there is you want to have this flexibility that I can pass any number of arguments for my function for whatever reason. You have this some weird use case where you want to allow any number of argument being passed into your function. So how you can do that? So for dynamic or variable or not fixed number of argument, if you want to pass, what you do something called star. You put the star in front of your args, and that basically means that all the variable that you're passing will be like dynamic. That means you can pass one, you can pass two, you can pass three, and it will go to same function, and it will take all this argument. So the question is, if you are able to pass the dynamic argument, so here there is a one-to-one mapping. You say a comma b, that means we are first, if you call my func one with, let's say, 2 comma 3, so 2 will go to a and 3 will go to b. That is something very, very clear. But what about a dynamic type? Like we don't have a b c. There's just one thing. So how all these 2 comma 3 comma 5 comma 7 will, like, how this 2 3 5 7 will assign to this single thing? So what it does, it takes all this argument that you're passing, and for the single star, it convert all of them into single tuple. So now your 2 3 3 4 will become a single tuple, and your arguments is basically tuple. Now, are you aware of tuple data type? Tuple is very similar to list, and just like a list, you can access them with index 0 1 2 3 4, but you cannot add to the list. You cannot change the dimension. You cannot change the size of the tuple. It's a unmutable data type. You can look for what is unmutable. I leave it to you, but it is unmutable data type. Your list is mutable data type. You can mutate your list. You can add elements. You can delete the elements. uh, tuple is unmutable. You cannot add, you cannot delete, you can just have as it is. And every time you try to change something, it will create the new instance, a separate copy, a separate variable, a separate memory location for the new tuple when you're trying to change the original tuple. So it will not do any kind of in place, in memory replacement. It will always create the new copy if you try to change anything into the original copy. So anyway, so this is a tuple, and that is happen. Now this is the case when you're passing a simple argument. But what if you pass something, let's say a equal to 2 and b equal to 3. So this is something also allowed in Python, right? uh, in the simple case, in the simple function, you can do either only 2 comma 3, or you can do a equal to 2, b equal to 3. And the advantage of doing that is you can also do this, and this is also valid. So in the simple function, if you have a comma b, if you want to pass values into different order, you can do that if you also give the name of that. So if you do b equal to 3, a equal to 2, then 3 will go to b, and 2 will go to a in the simple functions. So this is a semantic, this is the syntax that is already allowed in Python. So we are going to take advantage of this particular capability, or this functionality. And what we're going to do is, every time, instead of passing the single value, if you pass this kind of variable number of key value pair, you can capture them using uh, 2-star keyword argument. So with 2-star keyword argument, every time you pass key value pair, that the whole thing will be captured into dictionary, and your key will be in this pair. The key will be, or the left part will become your key, and right part will become your values. So now when you dynamically pass n1, n2, n3 equal to, let's say, 45, or m3 equal to, let's say, 40, whatever you pass here, how many number of key value pair you pass, that will basically convert it into dictionary. And now your keyword is basically, your keyword will become this dictionary. So so this is what you see here. So this is basically what does it means, that in any function, if you want to have dynamic number of key value pairs or single arguments, you can use single star args, double star keyword, to take this kind of variable number of arguments into your functions, and take them and use them. uh, does that make things more clear now? Okay, this is already covered in class. Okay, anyways, so let's keep moving. We have less time. We don't want to waste time on things that, important stuff. So let's come to lambda functions. So what is lambda functions basically? Lambda is the inline function. So inline function, also known as lambda. So Python has these capabilities where you can create inline functions. So these are the functions, of course, but they are inline. So how we do that? So you use this keyword called lambda. So lambda is the keyword to create your inline functions. So start with lambda. After lambda, you pass your input, then colon and output. So this is your input. So how to write inline function or lambda function? You type lambda, then you type your input arguments, then colon, and then output. So here, what you're trying to do here, lambda x comma y. So I'm passing two arguments or two inputs, and then output going to be sum of them. So just x plus y. I'm not writing the return here because it assumes that, because of one time inline function, it assumes that whatever you write after colon will be a return. So whatever the result of last compute here will be returned as a result. So we don't type return here. It is already assumed that whatever you do here will be written automatically. So three part. Part one is this keyword lambda. Part two is the input, and here it could be, and this is like a variable. This is like how many. It is up to you for defining a number of arguments. So it could be only x. It could be x comma y. It could be x comma y comma z. It could be x comma y comma p, q, r. However number of argument you want, you can get as any function, and then you finally have only one way to like return them. So this is your lambda function basically. So I think that makes things clear. Lambda, input and colon and output. And so now what we're going to do is, as I told you that, in Python, every function is an object. And, because it is an object, you can assign them, you can, transfer them, you can basically, treat them as an object. So Lambda is also a function. It is a special kind of function, but still it is a function. And because it is a special kind of function, you can treat it as an object. So what you're going to do, we can take this definition of a function, of an inline function, of a Lambda function or an object, and assign it to this variable called my inline. So let's run this and see what my inline look like. So as very similar to, we tried this type on the function initially, right? Like we define our function here, and we say what is the type of that thing, and we say it's a function. So you get the similar result here. So that means internally Lambda functions or regular functions both are, similar. They're object, they're type of function. And if you just, like do the my inline, it will also give the similar response as we have seen before with the my func, right? With the my func, when we try to do that, function main and then function and then, argument. So similarly here also for the lambda, we are getting the same thing: function main and this lambda and then x comma y, which are the arguments for the function. So uh, so the idea here is, lambda functions are nothing but a function. They are very similar to function. They behave like a function. The only difference is because they are inline, they have slightly different kind of syntax, but otherwise they are internally behave same as any other function. And now, like any other function, if you want to call the function, what you do, you type the function name and then you pass arguments. So, my inline, and when I say 2 comma 3, it do the addition, because I have defined here my lambda function as a x plus y. So my 2 is going to be x, my 3 is going to be y, and, as it is 2 comma 3, so, the output here is going to be x plus y. So that would be 5. So this is basically lambda function. Now let's try to, like, spice things up and try to, like, try different scenario. So again, my lambda x comma y comma z and colon. So this is my input. I am defining three input variables, three arguments, and then colon. And after colon, we are suggesting what is the output going to look like. So what our output look like? So let's break it down. So our output is a tuple. There's a comma. So, this is the first part of the tuple. This is the second part of the tuple. So first element going to be x plus y, and second element going to be z as it is. So this is our lambda, this is our input x, y, z, and this is our output. So let's call this function lambda function. So as you see, 1 comma 2, which will be passed as a x comma y. We are doing the addition here, so we get the 3 and 3 as it is, because, z we are returning as it is. So that's a 3. It's simple. There's nothing complex going on here. Lambda is very, it's just a function, but a bit fancy. And the use of this lambda function is like, hey, I want to pass function into another function, but I don't want something very complicated. I don't want to write, like, just for my simple operation, I don't write the separate function. Can I, write something very small and just, inline? So this is the smaller inline function that you can use when you want to write something faster and don't want to, write too much of the code. One of the idea of Python is like, do more with less code. So this is in the same spirit of Python, that we want to do more things with writing less code. And because we don't want to write a separate function, def, create something x comma y comma z, return x comma y comma z. I don't want to do all that kind of def and everything. I just want something very simple inline, so I can write the lambda function for that. And that is the use of lambda function, to, like, basically remove all the verbosity and complexity of writing the independent function. I can just write something like this and use that. And we will see where lambda is more useful, because it might not make sense right now why lambda is very useful, why you want to not write something like, so this is very similar to something like this: def my func x comma y comma z, return x plus y comma z. This lambda function and this thing are exactly same thing. There is no difference between them internally. When I'm calling it my func, or this lambda, they both the same thing. They both represent the same thing eternally. This is just much more fancier, much more shorter version of writing function. I don't need to write this, def and all that stuff. I don't need to like do all this kind of ceremony. I can just write this one line function and I'm done with that. So this is the use of lambda to shortcut this thing. So my func here is basically lambda whatever, xyz, that is xyz here, and I'm not writing return here, and x plus y comma z, that is the same thing, x plus y comma z. So this is the typical or traditional function, and this is the lambda version of this traditional function. They both are same thing, exactly same thing. So this is the lambda function basically. Now, why we use lambda function? So here's something which I wrote. Like every time you expect to pass function object, so you will see so many cases where you are expected to pass a function object, function as an object, function as an argument, and you should ideally be using lambda function. So in we will see some of the use case why we do that. So most of the time, when you're expected to find function object, you should pass lambda and not the whole thing, and because it doesn't require all these boilerplate things like docstring and everything. Now one more cautionary tale about using lambda. Never assign lambda expression to variable. So what we did here, we created lambda function and then assigned to variable. So this whole thing is defeating the purpose. The whole purpose of writing lambda is that we don't want to create all the boilerplate. We don't want to define the function. We don't want to give the name to the function. So lambda is like anonymous, like a function without a name. So although Python allow you to name your lambda function, but the best practice says that you should not do that. And if you're gonna name your lambda function, then just go ahead and write the whole function itself. Like if you're gonna name your function, then just go ahead and write the whole function itself, because naming your lambda function defeats the whole purpose of creating the lambda function, which is basically reduce the boilerplate and do something minimalistic. So so it says that as a best practice, you should never give the name or never assign your lambda function to the variable. This doesn't make sense, because if you want to do this, then just might as well do this one instead, which will make more sense. So we will see some use case where we don't need to do all this thing. We can just use the lambda. That will come later. So that is the use of lambda. Now, according to PEEP 8 style guide, so people are, if you don't know what is PEEP, PEEP is basically Python, specification. So, Python programming language is also basically a software which evolves, and, people contribute, and PEEP is the way to like basically trap everything. So if you search PEP Python, you will see all this, index of Python enhancement proposal. So, which is basically how the language evolved. And every time someone puts some proposal or some new capabilities, some new, things, it is documented here. And specifically PEEP 8, PEP8 is about, so you can see here. So these are the main famous PEEP versions. PEEP1 is about, guidelines, deprecation standards, language evolution, bug fixes. PEEP8 is about style guide for Python code. So how you should be writing Python. That is defined in this proposal, Python proposal, PEEP8. And then you can read and you can learn about, the idea of writing Python, like how you should be writing the Python code if you want to really learn the best way or the most Pythonic way to write the Python. You can go here. So this is what PEEP8 standards suggest, that you should never assign lambda expression to the variable. It is an anti-pattern. If you want to do that, then just define the function itself. Anyways, so now let's go ahead and learn about lambda functions and see how lambda function can be used. A quick time check. We are already. Madam, how much time do we have? Okay, lecture at 10, so I only have a couple of minutes. So what I'm gonna do is I'm gonna finish this example, and then we'll end it here, and we'll continue next time. So what we're gonna do is we're gonna use something called sorted. So to represent how the lambda can be used. So sorted is basically a user defined. uh, Python defined variable, Python defined method like a sum. Sorted will basically sort your arrays that you pass. So the first array that I'm going to pass here is going to be range. So you guys must be knowing about the range. Range is basically a constructor that will create the list -5 to 6. So I'm creating a list here -5, 6, and because it's a sorted, it allows me to pass like how you want to basically sort your list. So a key equal to function. So the sorting key I'm going to pass around as a function. So this is the key that should be used to sort an array. So how it will behave? Um, so the way it behaves is um, so range 5, 6. What it will create? Let me just print this thing here. So uh, so range -5, 6 will basically create this is my list that I'm passing here in the sorted. And what you're trying to say is please sort this list. And how you want to sort this list? Using this key. So this is the key that we will use to sort this list. So what is the key here? So key inside the key, what we'll pass? We'll pass a lambda function. And what this lambda function will do? This is basically squaring the square rooting the whole thing. So what this will do is it will take every key, every element in the list, pass to lambda function, and generate the output, and use that as a way to or use that as a way to basically sort the whole list. So what does that mean? Internally, your sorting method will create a second list internally, and that list will be defined by this lambda function. How? So this key will be basically what is so -5 go to x and x square. So -5 basically -5 square, that will be basically become 25. So assign 25 to this first element as a key. Then for -4, so -4 goes here, become -4 becomes -4 square, that is 16. So assign the 16 as a key for this. So assume that in the background -5 has a key as a 25, -4 has a key as a 16, -3 has a key as a 9, -2 has a key as 4, and -1 has a key as a 1, and likewise. So all these values will have their keys in behind, or internally, and your sorted will function will use those keys to sort this array. So what output will look like this, because 0 will have 0's key will be 0, -1's key will be 1, 1's key will be 1, so 1 1. So -2's key will be 4, and 2's key will be 4. So based on these keys that is assigned to each of this element, we will sort the whole thing. We'll sort this list. So sorting the list based on the keys. And what are the keys? So this lambda function will basically create the keys for each of this element. And for each of this element, every element will go in. So every element will be passed to this function, and the output of this function will basically tell that what is the key for that particular element. So for the 0, the key will be 0. For the -1, key will be 1, and this is not visible. So you are seeing the final output, not the behind the scene. So that's what this is. I think we are already there. So Ami madam, I will hand it over to you. We will continue this class later. Sorry for taking so much time. I almost assumed that we never gonna get over this the time.
I know, Nishant sir, you are having very good habit of teaching very nicely and in detail. So I ask you in the advance that whether you will be able to finish within this 1 hour or not. I was aware that you will take more time because I know that you would like to teach in detail only. So it is really good to have the functions knowledge in detail, and the higher order functions also means one function is passed to other, that way also you have taught. And though the dictionary was asked in the class, one or two students say that they don't know because might be they were absent in that class, but still you have taught them that also. That is really good. Otherwise, see, many a times people are getting irritated by such things that other students are saying yes and one or two are saying no. But patiently you have explained them also. We are very thankful to you for giving very good knowledge to our students and your juniors, right?
Right.
Too long back you were here. So these are your juniors, but after too many years, juniors, it seems odd, isn't it? So thank you, Nishan. And we'll again arrange this remaining topics as per your convenience. And yes, I'll request you to have the lecture in uh, evening of Indian Standard Time, because otherwise in the morning they are having the lectures from 9
Hmm.
to 1 at least. They attend the lectures, and then after, if we attend or if we arrange any such a lecture, then it will be good, but that will be a problem to you for your timing. Okay,
Right. Yeah.
so if it is convenient, then we'll be having the lecture in the evening according to Indian Standard Time.
Okay.
So
Yeah, we'll try for that.
yeah, तो सरस्वती देवी की कृपा से एक अच्छी शुरुआत इस सेमेस्टर में हो गई, that we are able to get very good knowledge from Nishan. So thank you, Nishan. And one thing is, I would like all of you to please open your webcam so we can have the photos. As many as you are having the webcam, please open that so we can have the photo. Yeah, Twinkle ma'am is there. Okay, Akhilesh, yes, Karuna ma'am. Yeah, yeah, as much as we can accommodate, right? Not all, but still change the layout. If we are able to have more tile, that will be better. Please open your webcam, बच्चों. बच्चों, please open your webcam so we can have the photo together. Hey, please don't leave, huh? Have the photo together. Yeah. Some of you have opened, so I can take the screenshot. Please smile. One photo. Wait a moment. Let me take some more. So we'll have the proper photos, right? Last. Yes. Thank you. Anyone would like to say anything about sir or whatever he taught? Yes, students?
Please leave your feedback on the message.
Ah, yeah, you can give the message also. Yes, Kimi, Kimi, you would like to say something? LR, LR.
Yes, ma'am.
કંઈક તો બોલો બેટા, થોડી ફીડબેક આપો.
Yes, ma'am. The lecture was very good,
Yeah,
very informative,
yeah.
and I will thank to the Nishan sir for very informative session. And
Yes,
we would like to arrange such lecture in future
yeah.
again. Thank you, sir.
Thank you. Hello, ma'am. Mm,
Yeah, okay, okay. Okay, so we can leave now and students can attend their next lecture. Thank you, Nishant. Goodbye.